asymptotes. So how do we find these two things of these various functions here? Anybody remember? For question J, part A says find the vertical and horizontal asymptotes. What do we do? Yes, Naila.
For the horizontal, aren't supposed to have the exponent?
Right. So for the horizontal asymptote, there are three rules, right? We have to look at the powers, right? Powers of the top and the bottom, okay? And there are three cases here. If the top wins, there is no HA, okay? The top wins, there's going to be no HA here, right? If they tie, if the powers tie, if there's a tie, that means that you divide the coefficients. What does coefficients mean? The numbers of the highest powered, I'm running out of room, variables. That was a lot to write, but it's the correct thing to say. And then finally, what happens if the bottom wins? Mario does. Yes, it is y equals 0, right? Alright, and remember with the HA it's y equals. And so we're going to go ahead and look at this one here. So with our function, so, 1 second Mariana, we will. So if we go back here, and if we look at our function, so what are my highest powers? This is 1 and 1, right? So we circle the highest powers here. And what case do we have here? Does the top win? Do they tie? Or does the bottom win?
Tie.
It's a tie. Why is it a tie?
Because they both have one exponent.
The exponent on each is 1, true?
Yes.
So therefore, I have this case here. So, how do I find the... So it's going to be y equals... It's going to be, we divide the coefficients, right? What are the coefficients here? 3 and 1, right? Another way of seeing it is you could just pull them out and just say, what is 3x over 1x? See how the 1x's cancel? 3 over 1. So the horizontal asymptote is y equals what? 3. And it is y equals. It's important. Make sure you put y equals. It is y equals. Okay? Excellent job. And now, or any questions on horizontal asymptote? Other questions here? Jason? Absolutely. Sub-example here. So here's an example here. Alright, I just made one up. So now, we look at the highest powers, which are where? Here. Who wins? The top or the bottom? Top. So there's what? No HA. Correct. Another example here. A common one. Now, the power on the bottom is 1. What's the power on top? No. It's x to the 0. If there's nothing there, it's x to the 0, right? So, another way of thinking about that, if you just have a number. Well, if there's no variable, there's no x, so the x power is 0, right? Because if there is no variable, you can think of that as like 2x to the 0, right? And now you can use this for analysis. So 0 and 1, and who wins? Which power wins? The bottom, so it is y equals what? 0, which makes sense because, if you guys see here, look at this function here. Look, the horizontal asymptote is at y equals 0. See? Because the bottom wins. Bottom power wins. Cool. Thank you, Jason, for that clarification. And finally, on to the vertical asymptote, which is much easier to ascertain. Karina, what does ascertain mean? To get, to acquire. So, how do I find the vertical asymptote over here? Maria, do you remember? Very good. We get snaps for Maria for remembering. There you go, Maria. So, set denominator equal to 0. So let's go ahead and do that here. So clearly my denominator, even though my picture looks rather convoluted now because of all of my writing, is x minus 5. So I get x minus 5 is 0. Now what? Yeah, I'm going to solve for x here. So what do we get? X is 5. There we go. Whoops, sorry you can't see. Please put that in a box, and we are done with part A here. Okay? Part A is completed. It's all done. What's wrong? Is it good? Alright. Move closer, Mariana. There's a desk here. Alright. So that's the easy part here. For part B, it says find the x and y intercepts. So the x-intercept is another way of, that's basically like the roots, right? And how do we find the roots? Anybody remember? Set blank equal to 0 and solve. Cool. Does anybody know what the blank is?
Is that the blank? Wait.
No. Hold on. Nope. No. Set y equal to 0. The roots, you always set y equal to 0 first and solve. So doing that here, if you have 3x minus 4 over x minus 5 equals 0. Solving this one is pretty simple. Why?
Is equal to 0.
Yeah. So what do I do? What? Yeah. Multiply both sides by x minus 5 to cancel the denominator. So these go away. And what am I left with? Equals what? What does this give me? 0. That's why it's easy, right? And now we solve this out. And what's the answer? It's 4/3, right? Right? X-intercept. The y-intercept is the exact same thing but reversed. Who can guess how to find the y-intercept? Yeah. Set what? X equal to 0 and solve. In this case for y. So if I write my function, it is 3x minus 4 over x minus 5, and that's y equals true. If I set x equal to 0, what will this give me here? 3 times 0 minus 4 over 0 minus 5. What does this give me here? This is 4/5, and this is my y. Right? Negative and negative is positive. Right? There you go. These are my intercepts. That's it. That makes sense? Cool. All right. So now we're going to move on to part C. We good? Questions here? Questions. Questions. Okay, cool. We haven't really reviewed a whole lot x and y intercept. It's been a while, probably. Which one? It's y. Y equals 4. 4/5. Question? Maybe. Depends on what you guys need. All right, part C. Part C says, make a sketch of f of x below. Make sure to label your intercepts and asymptotes. So my vertical asymptote was at what, 5? It's x equals 5. True. What's my horizontal asymptote? At y equals what? Okay, so let's go it out. So I'd go to x equals 5, put a dotted line. This is my way of burning time. Alright, cool. And now I go to y equals what? 3, and it's horizontal. So what's a good tune to sing this to? Yeah, yeah. You're allowed to sing bop when you make your horizontal asymptote. It's a new rule. It's the Hansen horizontal asymptote corollary. Maybe, yeah. But you have to be making the asymptote though. Can't just be doing it any other time. All right. So now you know what it looks like. It is 3x minus 4 over x minus 5. Question: is there a negative here? Yeah. So it looks just like that guy, right? All right. Here we go. Ready? Whee! And where does it hit the y-axis? What was my y-intercept at? Where was it at? My y-intercept was at where? 4/5, which is 0.8, right? So that means it hits here at like 0.8, which is here. And what's my x-intercept? It was 4/3. 4 into 3 is 1.33, right? So it's going to be, so that's on the x-axis, 1.33 is here. And you can see that kind of makes sense. So like when you draw it, it's going to make sense that it's actually going to pass through those points here. And we got this. Oh yeah! Alright, any questions here? Alright, part D. Let's read part D. Jonathan, could you read part D for us once you're done making your cool curve?
Based on the graph above, determine the intervals of where f of x is increasing and decreasing.
Alright, does anyone know this? Anyone want to take a stab? Where is it? Let's do increasing first. Who knows? Mario knows. Mario, where is it increasing? He says it's 5 to infinity. Do we agree? Let's check it out. So from here to here, he says it's increasing, yes? Yes? Right?
Yes.
Okay. So when it's increasing and decreasing, this is what I want you to do. Write this down. Draw a car. Why? Because it sounds silly and ridiculous, but it's impossible to get it wrong if you draw a car. Now, ready? Here we go. Let's draw like... Oh man, it sucks. Alright. Alright. Here we go. Here's my car. Now we drive from... I know. We drive from left to right, true? Now as the car goes this way, is the car... Increasing means he's moving up, true? Decreasing means he's going where? Down. It's pretty obvious. Is the car going up or down? Down. So, since I know he's going down, that means he's decreasing from where? Negative infinity to who? To 5. True? Parentheses. Now this car goes and crashes and, explodes. Oh! Alright. But another car is up here. So if you have a part where your function is discontinuous, where you have a vertical asymptote, what you need to do is you need to draw another car here. Okay? Starting up here, so let's draw my car. Maybe I can make this one a little more impressive. Somebody said my car looked like a shoe. Okay? Get you wherever you were. Just kidding. Have like the Batmobile car. I don't know. It looks more like the Batmobile that like... Maybe he's carrying... It looks like he's carrying like a picture on top or something. I don't know. Alright. So now, as I draw my car this way, question, what is my car doing? Is it going up or moving down? It's going down again. What does that imply? It's decreasing. So my decreasing interval is incomplete. True? It's decreasing from where? 5 to infinity. So thus, what does this imply? There is no increasing. Question, who can tell Mario what... Or Mario, do you know what you were confusing it with? What? Concavity, which is the happy face, right? So now, part E, it says, where are the intervals of concavity? Underline concavity, please. With the concavity, put happy face, sad face, okay? And as you can clearly see here, these are the faces here. So if you put your eyes on your function here, you can clearly see, and we're going to abbreviate here. Who can tell me here, Brianna, where is it concave down from? To what? To 5 is correct. Does anyone have any questions on Brianna's claim here? It is correct claim. Does anyone want to dispute that? Everyone see that as to why that's true? Cool. And finally, concave up, which is from where? Whoops. Cup. Which is from where, Mario? True. Alrighty, excellent job here. And that is how you are...